Hello everyone, I'm David Bryant. I am a Mozilla Technical Fellow in our Emerging Technologies organization. I'm going to pick up on some things where Ali left off, and I kind of have three goals during the course of the next 20-ish minutes. Hang on a second. To accomplish with you all. One is I want to take you on a behind-the-scenes tour of some of the technologies that are in Firefox today. I'll highlight a number of things that are related to what Ali talked about in Firefox 57 that we're building the 57 release around. But I'm going to talk about some other things, a few things that got into Firefox before 57, some that you can play with that aren't going to be ready for prime time in 57. The idea is to sort of give you a view of all of that technology, and maybe some parts of it will be more or less interesting to you. Second goal is to introduce you to the Emerging Technologies organization. People, I'm sure, would expect that we have a large engineering organization at Mozilla that builds Firefox. The second largest engineering organization is Emerging Technologies, and it would be useful, I think, to sort of get you acquainted with that. And then the third one is I know you're all web developers, so I'm going to try and hit some points along the way in the talk, and then give you some opportunities or some homework to engage around some of our technologies and maybe tee up some of the other topics that we're going to talk about this afternoon. And the image you see on the screen here is, as much as you might think, is not a marketing slide. This is actually how we think about Firefox 57. This is the Mark 57 supersuit. And it is really sort of visually representative of the work that's gone into Firefox 57. And if you look at this graphic closely, you'll have an opportunity to be rickrolled, if that's a thing that's meaningful to you. And you'll get a feel for some of the stuff that's going on inside of Firefox. And so hopefully by the time we get to the end, you'll have more of a sense for what it's like to wear the Mark 57, and then you can actually go and do it. All right, so the Emerging Technologies group grew out of the research organization at Mozilla. We've had a research team for quite a long time. Sort of historically, the focus of research at Mozilla has been about building a better web engine. Not surprisingly, with Firefox as our primary product in our business, we wanted forward-looking exploratory work in technology areas that would anticipate the next generation of that web engine. And so JavaScript, web standards, those sorts of things. What you would logically expect would be exploratory work in a web browser company is sort of the history of Mozilla research. And about a year ago, we realized that there was an opportunity for us to actually take a broader perspective and to expand the foundations of the open web. So we transformed our research organization into Emerging Technologies and expanded our charter to be much more about anticipating the components and elements that were needed to build a much wider range of experiences on the web. So one of the things you're going to hear about and actually have an opportunity to experience today is the results of a bunch of that work in progress. And so we're really keen to expand our view of the web as a platform substantially beyond what the core web browser experience is like today, but also put all of that technology in consumers' hands and put it in your hands as a developer so you can take advantage of it. So I'm going to walk through a couple of examples of that sort of, research, emerging technologies leading to something interesting in Firefox that you can all experience today. And the first one of these sort of narratives starts in 2009 when we spun up a research project at Mozilla around a new programming language we called Rust. And the tagline or mantra for Rust was fearless concurrency. Fearless because we'd learned quite a bit from building Firefox. It's, 6 or 8 million lines of C or C++. So it's a large, complicated blob of system-level software. And we'd learned that that actually can be a pretty scary thing, and particularly when you think about things having to do with security vulnerabilities, misbehavior in terms of memory and user crashes. Those are all generally rooted in a core set of software engineering challenges, and we thought it would be great if we could make a programming language that would prevent developers from having to deal with some kind of those problems, either in development or worse, in deployment after your product is in the hands of hundreds of millions of users. The concurrency part of the idea behind Rust was to take advantage of the opportunity to better parallelize things. This was 2009 when we did this. In those days, it was sort of the early days of the explosion of multi-core hardware. So we were obviously seeing multi-core CPUs in laptops and desktops, but we also were seeing them come into the mobile phone. So the tiny little computer you have in your pocket, or that you're using now to text someone rather than listening to my talk, is actually a multi-core machine that's very, very, very capable. And the web was expanding rather rapidly. Hardware was expanding rather rapidly. And as a software application maker, we were kind of in the middle in this unpleasant place where people wanted more out of our platform, the hardware could do more, and we were struggling in the middle trying to figure out how to give them that. So a lot of thought in designing the Rust programming language was oriented around how to make concurrency better. And if as a developer you've ever tried to take a complex thing and break it down into independent parallelizable tasks, you know how challenging that can be. And so if we could magically give you that in the programming language, that should be awesome. And so we started work on Rust in 2009 as a research project, as an open community effort. And by 2012, the language had developed sufficiently that we were ready to actually put it into use. And so in 2012, we launched sort of the companion project, Servo. And the idea of Servo was to design and build a modern, performant web browser, a browser engine in particular, to take advantage of the benefits of Rust. So obviously the fearless part, although that's not necessarily so visible to end users, but certainly the concurrency part, so because that is visible to end users. And Servo served as a great sort of a workbench. We could take Servo as an independent browser engine, not really critical path for anything, and step back and rethink the architecture of other existing browser engines, looking for ways to benefit as much as possible from concurrency and parallelization. And over the course of several years of working with Servo, we tried some things that didn't work so well. We found a number of things that worked really phenomenally well. And by the, I don't know, about this time last year, October of 2016, we'd seen enough of the progression from Rust and Servo, and we'd sort of gotten comfortable with the potential that they had showed to announce a broader initiative which we call Project Quantum, which was designed, amongst other things, to extract these technological benefits from Servo and Rust and put them in Firefox. And so when Ali mentioned earlier that work has driven a lot of what's in Firefox 57, that's actually something that you can, if you haven't already, download and experience today. So for example, the CSS style system in Servo deeply parallelized to take advantage of the fact that styling on the web today happens to be something that's really amenable to being parallelized. It's just hard to do. It proved out to be a subsystem that we could extract from Servo, make some changes around a little bit, and then integrate it directly into Gecko for Firefox. And so we call that Quantum CSS. Engineers, of course, like to make up code names for things, and so the engineers codenamed it Stylo. And so you may have heard us talk about externally in some of our blog posts or even tweeting about getting Stylo in Firefox 57 and getting it out into the market. So what you can see here is this progression, and there are other examples that Project Quantum has done or will do. We'll talk a little bit more about them later today too, of a 2009 programming language project. And maybe programming language is not something that you think Mozilla would invest in as an exploratory effort, leading to breakthrough implementations and algorithms and software components which they can then put in the browser, get out into the world, put in the hands of all our users, and you can actually see and feel a substantial increase in the performance and responsiveness of Firefox as a result of this work. So pretty happy about that example. And the left two pieces and like half of the right-hand piece is all work that was done in emerging technologies. All right, so here's another example that I don't think Ali mentioned, so we may give you a little more background. Here is something called WebAssembly. How many folks have heard of or know anything about WebAssembly? And I know those of you, excellent, that's good. I don't normally get that many hands. So here's another history story. 2008 to 2010 as a period of time we sort of call the performance wars, the JavaScript performance wars. You may not have been aware of it, but most of the browser vendors were spending a lot of time and energy during that period figuring out how to make their JavaScript interpreters inside the browsers much, much faster. A lot of good programming and computer science went into that. We introduced things like just-in-time compilation and active dynamic optimizations in the JavaScript interpreter. And that worked really well because we got about a 10x improvement in the performance and throughput of JavaScript relative to what it had been before. But of course, you know, when you're thinking in a more exploratory, researchy way, you don't want to stop there. And so we had a small team of people that stepped back and said, how can we get even more performance out of the JavaScript engine inside of the browser? It's going to be more critical over time, and we better get to work on it. And so they challenged a bunch of our fundamental assumptions about JavaScript. One is, historically, and probably still today, JavaScript is a source programming language. You're programmers, you fire up your favorite editor or edit your programming tool, and you write program in JavaScript. That's what the language was intended to do, but that doesn't necessarily mean that's all it can do. So one of the questions we asked ourselves was, what if instead of treating JavaScript as a sort of humans do programming kind of programming language, we looked at it as an intermediate representation that we could then feed to the browser. And if we could simplify the browser's job in running JavaScript and executing it, we could get some more performance out of it. There are aspects of the JavaScript language, it's a dynamic language, for example, that make life harder for the optimizer inside of the JavaScript virtual machine or interpreter. And so one great immediate benefit of that was we could make a lot of that more difficult stuff not part of the picture. So JavaScript as an intermediate language turned out to be a performance benefit. And the other thing that let us do was we could do a lot more aggressive optimizations, ahead of time optimizations, and do them upstream before the JavaScript ever got fed to the browser. One of the great challenges of JavaScript in the web is that all of the work to parse, optimize, and load JavaScript happens exactly when the user clicks on the link to load the page. And so every millisecond that's taken in order to download the JavaScript and parse it and optimize it and get it up and running is time that the user is drumming their fingers, waiting for something to happen, and maybe deciding to navigate away from the page and visit another website. So the idea of using JavaScript as an intermediate language led to something called asm.js, which was, I guess, last year, so 2016. Something that was complete enough to be used in all of the browsers. And one of the great advantages of asm.js is that it's a subset of JavaScript. So this means that we didn't actually have to add asm.js interpreters to the browsers. The browsers could actually already download and run the code. So if you're interested, you too can program and package up pieces of your application using asm.js. The way you do that is you start with your source program in some programming language. We have tools to actually strip that down and turn it into the subset of JavaScript that asm.js represents. And then that becomes the payload that you associate with your assets on the web and that get downloaded and run in your browser. And we see people actually doing that, in particular using it for sort of computationally expensive tasks that you would do as part of a web app, like face recognition in uploading a picture, or encrypting data as part of securely transmitting it from a web application to some backend service. And so asm.js was successful, and it convinced us that it was a good idea and that we were on the right path. But of course, in research, you're always like, okay, well, so what else? What other crazy thing can we do? And the next obvious step from that perspective was to actually turn that intermediate representation from JavaScript into a binary form. And that was the genesis of the idea for WebAssembly. So that was a long historical way of getting you to the concept that WebAssembly is essentially a virtual CPU inside your browser. There are tools as part of the WebAssembly tool chain that will let you take source code in C or some other programming language, compile them down and turn them into a binary executable with a standards-based predefined format. And then that binary executable becomes part of the asset collection for your web page that gets downloaded and run by the browser. So this is what that looks like. I just walked you through the process. You take your, I don't think I have a pointer, so I'll point. You take your C or C++ or other programming language source code, maybe from a development team that doesn't really know anything about developing and programming for the web, but they're really good at writing code that does face recognition or machine learning or something. And you can compile that down with a WebAssembly tool chain and produce this binary module that is then readily processable in the browser by the browser. Now, there are a couple of interesting properties of WebAssembly that make this maybe even more interesting than you might think. One is it's a W3C standard. So the other browser, all of the browser vendors, I shouldn't say other, all of the browser vendors were impressed with the progress of asm.js. They liked the idea of WebAssembly. And in fact, they embraced it wholeheartedly to the point of even abandoning some work that they had been doing on native and other kinds of approaches to solving the same problem. And so we're to the point now where 58% of the browsers running in the world today, desktop browsers running in the world today, support WebAssembly. And that's a particularly good number because that does not include Microsoft or Apple. Apple has added support for WebAssembly in Safari 11, which is actually releasing now as part of the iOS and macOS update. And so there's 0 deployed instances of Apple machines running WebAssembly today, but that's changing this week. Microsoft actually also hasn't yet released support for WebAssembly. It's in Edge 16, which is coming in the, let me get this right, the fall Windows 10 Creators Update, which will be available in the middle of October. So we're at 60% penetration of this very powerful, performance-oriented web platform technology and haven't even really gotten Microsoft and Apple into the mix. So by the end of the year, the number will be way bigger than 60%. Another interesting quality of WebAssembly is that it allows us to actually abandon the idea of browser plugins. If you've been building web apps or web-based experiences for a while, you've probably seen or had to rely on a native language plugin to the browser, maybe because you were using Flash, for example, as part of your web app. Finally, with WebAssembly, both because it has such a strong set of performance qualities and because it's possible to take most any programming language and compile it down into that binary form, we no longer need to have native language plugin support in the browsers. And so as browser vendors have embraced WebAssembly and made it available, they've deprecated their plugin APIs. As content providers and toolchain vendors have seen the growth in the deployment of WebAssembly, they've deprecated their use of plugins and Flash on the web. And so we're to the point now where if you want to build a very complicated, sophisticated application, you can do it entirely in web technologies, entirely deployable and runnable in an off-the-shelf end-user browser. No plugins required, and no dependency on external code. Reduces the security vulnerabilities and the performance unpredictabilities. And so we're really to the point now where you can imagine as complicated a web experience as you can think of, and we put the tools in your hands to make it possible for you to actually build and deliver that entirely using web technologies on and for the web. And so WebAssembly is still early from people using it for things perspective, but it's available and supported, and depending on the nature of what you're doing. So WebAssembly, it's a thing. You can use it. Check it out. One of the other great things about WebAssembly, I think I've said that several times now, but yet another great thing about WebAssembly is that you don't actually have to use it to get the benefits of it. And that's because what we're expecting to see is that sort of tool chain vendors will begin to deliver, you know, when you get to the point where you've built a thing, like you built a great video game using Unity or Epic Games, and you hit the publish to web button to spit out your game so that you can deploy it and let people play it on the web, it will actually take advantage of WebAssembly underneath. And that payload that gets built out of that tool chain will take advantage of WebAssembly, and you don't even know it's there. Another good example is that frameworks vendors can do the same thing. So if you're using a popular web framework in designing and building your application, it's probably the case that that framework today is not taking advantage of WebAssembly. They minimize their JavaScript or do other clever things. But we're to the point now, especially with the broader deployment of WebAssembly, where they can repackage those frameworks to take advantage of WebAssembly. And again, you won't have to change your code. You'll just get the benefits of WebAssembly from a performance perspective without having to do anything. So hopefully that will make you happy. A couple of other things to highlight that are in Firefox today so that you can play with them as an end user or you can take advantage of them as a developer. One is WebVR. And you can tell we're set up to actually give you a look at WebVR. This is the point in talking to people where I always ask, how many people have not ever had a VR headset on? Never, ever. In their entire life. That's excellent. Only like 3 or 4 people. If you haven't, sorry, Fabian. If you haven't had a VR headset on, you definitely should do it. We've talked about just sort of trundling a machine around on the streets and letting people take a VR test experience. So VR is a great new kind of experience. Remember I mentioned this is a part of our philosophy in emerging technologies. So I'll talk a little bit about that. And then speech, hold that thought because that's another one. So here's our WebVR. This is Firefox. We're in a VR headset. Not sure exactly what kind of virtual reality appeals to a fox, but WebVR is, in essence, the web extrapolated to make VR possible. So it's a JavaScript API that you can use alongside all of the other JavaScript APIs you have, and it lets you talk to the VR headset. So you need to be able to expand your web application to understand that you have a headset, to treat it as a display, to understand that there are sensors that are associated with the VR headset to tell which way the user's looking, and are they standing up or sitting down. And then you'll see here in a little while there's controllers that are used in VR. That's how you like wield the sword or paint a picture or carve a turkey. And so the WebVR API, there you go. The WebVR API gives you the mechanisms you need in code to talk to those controllers and figure out what's going on. So in essence, we've extended the basic JavaScript web device API concept to apply to VR headsets and make it work. WebVR is a W3C standard. We're at version 1.1, and we shipped full support for WebVR 1.1. We're the first browser, first desktop browser to do so to end users in Firefox 55. So there are tens to hundreds of millions of browsers on people's desktops out in the world that are totally capable of running a VR experience and talking to a VR headset. That's just part of the picture, though. If you're going to do that and sort of give users the ability to experience virtual reality, you want to create some world for them to actually be in. And so A-Frame is a way of making it possible to do that. And again, we've followed the same philosophy by taking what you already know and can do as a web developer and just extrapolating it so that it works for VR. So in particular, A-Frame is essentially a way of building an HTML formatted document that in the end gets treated as or generates a virtual reality scene or multiple scenes that you can interact with. And so I don't know if we'll get a chance to do it today, but you can actually sit down in a very few minutes. You can take a simple HTML document template, add a few tags to it, and suddenly have created a virtual world that you can experience on your desktop machine, on your laptop, or in a headset. And just like WebVR, A-Frame is totally open source. You can contribute as well as use it, and you'll actually see A-Frame in action when you try on the VR headsets or watch us play with it later today. Another thing you probably heard a lot about is augmented reality. Augmented reality and virtual reality are kind of two ends of a spectrum, and that aggregate collection of technologies is called mixed reality. And one of the great things about the web and the work we've done with WebVR and A-Frame is that we can easily extend those concepts to mixed reality and augmented reality. So A-Frame as a construction tool is easy to use with JavaScript to build augmented reality experiences or mixed reality experiences. And the WebVR APIs that we use to talk to headsets and the device can actually be used and extended to do augmented reality. So again, the idea here is you're already web developers, you already know how to build content for the web and experiences on the web. We want you to be easily able to build mixed reality and virtual reality experiences using all the same skills and tools that you're using today. Mixed reality support's not yet something that's fully available in Firefox, but because all of the WebVR pieces are already there and supported, you can get started today, and we have projects underway to work with people on that. Last piece of alternative, weird, new experiences I'm going to highlight is speech. I'm sure you're all aware the world today is all about expanding the ways you can interact with your car or your garage door or your blender by letting you talk to them and ask them questions. And that's a great thing, but the unfortunate truth is the history of most of that speech technology is not open and accessible and available to everyone, and that's a problem. We'd like it to be just as easy for you to build speech interfaces to your web applications and content as any other kind of experience. And so Deep Speech is a project that we announced at Mozilla Emerging Technologies earlier this year, and the idea is to design and build a completely open source, royalty-free, usable by anyone speech recognition engine. So if you want to add speech in some way, shape, or form to your existing web experience or app, not a problem. Deep Speech is available. The code's on GitHub. You can check it out. And it's something that we've actually, in a minute, I'll show you how we're using it to deploy this kind of thing in the real world in Firefox. Now, another interesting truth about speech recognition is just having an engine doesn't really do you very much good, because while it's capable of recognizing things, it doesn't actually have the information it needs to do that recognition. Speech recognition is a very machine learning oriented kind of thing. And so simultaneously with announcing Deep Speech, we announced a project called Common Voice. And Common Voice is our effort to actually get to build a rich speech data set, what's called a corpus in the speech recognition field, that we can feed into Deep Speech as an engine, or that you can use with Deep Speech in using it in your applications to provide the recognition, high accuracy, low word error rate speech recognition in whatever language it is you're trying to build into your speech-based app. And so what you do with Common Voice, it's a website. The link's not here. But you go to the website and you can do two things. You can either contribute your voice. We'll pop up some phrases and ask you to read them, and we'll record what you contribute. Or if you're maybe a little self-conscious about recording your speech and you don't want to do that, you can also validate other people's contributions. So we'll play back the snippets that we've recorded from other people and ask you, did they say what we wanted them to say? And so far, since we've launched the site, we've had over 500,000 contributions, both in terms of speech segments and speech validations, from users who just want to take a few minutes and help out and help us build this data set. The good news is, of course, is as we build this data set, it's not only available for us with Deep Speech, but it's also available for you to use. So we're down to the last 2 minutes of content. And this is the part where I summarize all the things that are available to you to get involved and be part of working with us around this range of technology. So obviously A-Frame, you'll see it later. You can easily, during the lunch break, build some virtual reality thing using A-Frame, and we'll help you do that. We've taken Deep Speech as an engine, and we've collected up a bunch of data from Project Common Voice, and we built a test pilot add-on for Firefox. So if you're familiar with test pilot, it's a way of letting us experiment with possible ways of adding functionality to Firefox. And we've created a test pilot called VoiceFill. And the purpose of VoiceFill is to do something that I know you actually already do, and that's talk to your browser. And with VoiceFill, we add a little microphone button to a wide range of search engine pages and other sort of standards web front ends. You can go to that page, so you go to your favorite search engine, you can click on the microphone button, and instead of typing in the search query, you can just say it. And as an extension, VoiceFill will listen to what you say, it will convert it into text, it will inject that into the search, and then you'll get back the search results where you actually never had to type the query into the browser. So you can play with that, see what you think. It's a web extension, and you could build on it and do other things if you like. I mentioned Project Common Voice. The opportunity for getting involved or contributing there is to help us with your voice or validate the contributions of others. And then web extensions now are web things. You can use HTML, CSS, JavaScript development skills to build a web extension. So between WebAssembly and web extensions, if you've always wanted to add features to browsers but never had the ability to do so, that's no longer true. You can knock yourselves out. One way or the other, those technologies will let you do something in a browser that the browser vendors maybe never intended, but that you've always wanted to make happen. So with that, I'm at the end of time. I would like to thank you for listening. The logo in the upper right corner is to remind me to remind you to download Firefox 57 if you haven't already, or the developer edition, which went live yesterday with Firefox 57. So either one of those or both are great ways to see a bunch of the technologies that we've talked about, get involved and develop with them and add them to the portfolio of what you're doing. And then obviously, if you have any questions or comments or want to know more about any of the rest of this, we are more than happy to talk to you about that. So with that, I think I will turn it over to Fabian for VR. Thank you.